these are gonna be due Wednesday, not tonight. I just need to fix that, I'll do later today. But the homework and the quiz for this section will be due Wednesday night, not tonight. Let me look back at my notes and see what these ones. Okay, so I guess I can just mention this. Number 2 on the homework, it asks the probability that a player is dealt a particular hand in this card game is 0.33. And they say, explain what this probability means, and if you play this 100 times, will you be dealt this hand exactly 33 times? And it's not going to be exactly. Whenever we're doing these probabilities, it's always going to be approximate. It's never going to give us exactly 33. That's just how many you would anticipate that it would be, but it might be 34, it might be 32, it might be 40. You don't know, but it should be somewhere around 33, you would think. So you're just going to interpret them approximately. Here, 33 out of every 100 dealt hands will be that particular hand, so it's always approximately, never exact when we're dealing with these probabilities, because it just talks about what's happening. This probability is based on what's happening long term. It doesn't guarantee what's going to happen in the short term. So in this case, approximately, no, you will not be dealt this hand exactly 33 times, since probability refers to what is expected in the long term, not the short term. So you would select C for that then. Just keep in mind, probability doesn't tell us short term with any kind of guarantee. It just kind of gives us an idea. All right, so for number 3, Bob's doing a probability model for rolling a pair of fair dice. So he's gonna roll 2 die and then add them together to see what their sum is. So the outcomes are gonna be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then he says the probability of rolling a 7 is 1 out of 11. And then it asks you what's wrong with Bob's reasoning. Does anybody know what's wrong with that? Say it again? B? Right. So the experiment does not have equally likely outcomes. So if you look at the different ways you can get a 2, if you're rolling a pair of dice, you can get a 1 and a 1, and that's really it. That's your only options. So there's only one way you can get a 2. But if you're looking at rolling a 7, you could do a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. So there's 6 different ways you can possibly get it. So they're not going to have equally likely outcomes. Rolling a 7 is a lot more likely than rolling a 2. That's the problem with that one. All right. Let's see what else I've got. Okay, well, this one I actually talked about already with the notes, but for part B, it asks you to find the probability that it lands in slot marked 5. That's going to be right here. You just calculate that in your calculator. And then it says to interpret this is going to be the sub part that they'll ask you for, the little follow-up question. And they say if you spin it 1,000 times, it is expected that about, not exactly, because it's not going to be exactly if it's short term. It's going to be about an approximation. And then what you're going to do is you're going to take this number here and multiply it by 1,000. And you should get 18 when you do that. So that's the number that you'll put in there. So for this one, it's always going to be about. It's never going to be the exactly. So click on about, multiply this number that they give you. In this case, it's 1,000. It might be 100. It might be 1,000,000. Whatever number they happen to give you, multiply it by the probability, and then you're going to get this number right here. Same thing down here. Calculate this probability, and then down here, it's about, not the exactly, it's going to be about, but they took this number and they multiplied it by, in this case it's 100, the other one was 1,000, but this one's 100, so they took this probability, multiplied it by 100 to get 48. So that's that follow-up question. So number 8 on the homework, it says the median was given. What's the probability that a randomly selected family has an income less than that? So in this case, you're not really using any of the methods that we talked about before. You're just using the fact that if it's the median separates it in half. So you've got 50% of the data values are larger than it, 50% of the data values are smaller than it. So it says, what's the probability that the income was less than 57,700? Well, that's going to be half the people are less than it, half the people are greater than it. So as a decimal, it would just be 0.5 for that one. That's just from the definition of median. So for this one, they just ask you, here's S, that's our sample space. So we're looking at all the numbers between 7 and 18. Here's our E, 8, 9, 10, and 11. Here's G, 14, 15, and 16, and 17. And so they're looking at which ones they have in common. In this case, they don't have any numbers in common. These are all less than 11. These are all greater than 14. So they don't have any number that's in both E and G. So when you select that one, you're going to want to do B, where there's just this curly bracket with nothing in it. That's going to be the empty set. Number 9. Disjoint, whichever, they mean the same thing. Then E and G is just going to be that. Nothing in there, and that's just stating that it's the empty set. There's nothing that they have in common. If they do have something in common, say if they had 12, you would select this one up here and you would type a 12 in there for what they have in common. If they have a 12 and a 13, you would still select this one and then type in 12, 13 for what they have in common. So that's just a little bit of notation that we didn't go over. Like I said, I'm going to move those due dates back a little bit. But we were supposed to cover 6.1 today. We're not going to get all the way through it, but I'm just going to start on it a little bit.